Hi folks! So this week we are exploring books that are an author's point of view. The books in this text set are all nonfiction and they focus on different environmental protection and conservation issues. The author is presenting factual information and readers will explore the questions of why an author chooses to write about a particular subject and what message they are conveying. In this series, readers will learn that sometimes authors have a specific point of view on an issue. And as the readers, we can evaluate the information provided and think more about our own experiences and perspectives and synthesize those existing thinking with new ideas. Our first book that we are going to read is called What's So Bad About Gasoline? So every day people fill their cars with gasoline. The author thinks that this is a problem. What do you think? Here's the front cover of our book. It's written by Anne Rockwell and illustrated by Paul Measle. Take a look at this picture. What do you see in the picture? What are you thinking? Here's our end pages. That's a close-up of that traffic jam on the bridge that was on the cover. What's so bad about gasoline? We go to the gas station and fill up the tanks of our cars, and we're ready to go. Anywhere, everywhere, in big cars, small cars, all kinds of cars. Gasoline is what makes cars go. What is gasoline anyway? Gasoline is a kind of fuel. When it's burned, it gives engines power. But carbon dioxide, other gases, and small particles of ash go into the atmosphere as the fuel burns. These are called emissions. Here's a little diagram. It's our gas tank, muffler. The engine burns fuel, and you can see the emission is carbon dioxide released into the atmosphere, creates a greenhouse effect. Carbon dioxide is a gas that traps heat above the Earth's atmosphere. Too much carbon dioxide in the atmosphere makes the Earth warmer than it should be. We call this global warming. The planet's heat gets trapped. Every year, more and more people all over the world drive cars, and every year the Earth grows warmer. Gasoline is made from petroleum, which is a fossil fuel. Fossils are what remain of plants and animals that lived millions or billions of years ago. Maybe you've seen some in stone. You can't see the ones that make petroleum, for they are too tiny, but they are there. Here's an example of a stone with a leaf fossil. Microscopic algae. Long ago, tiny plants and animals lived in the ocean that covered much of the earth. When these plants and animals died, they drifted down to the ocean floor. As millions of years passed, they became covered with sand. As more time passed, the sand turned to rock. Here's the ocean, here's sand, here's rock, and here is the oil. The decaying matter from the tiny plants and animals was trapped beneath the rocks. This trapped decaying matter changed into petroleum. Some of the oceans dried up and left huge petroleum deposits deep underground. Some petroleum remained under the water of the ocean. These deposits under land or sea are where we get petroleum or crude oil to make gasoline. Are they drilling in the desert? Yes, there used to be an ocean there. That's on the water. Yep, it's as big as a city block. Wow. So on these first pages, the author is giving us a lot of information about gasoline and where it comes from. Think about what you've learned so far about gasoline that you didn't know before. People knew about petroleum long ago. There is more in the Middle East than anywhere else in the world. In the sandy desert of those lands, people sometimes found sand that was moist and oily. Petroleum had seeped up through the ground. They used this oily material to waterproof boats, to preserve mummies, or to rub on their dry skin. They never tried to dig up more because they didn't need to. They didn't use much. Petroleum is still used today to make skin lotions. Bitumen is thickened petroleum that is still used in road paving. Ancient builders used it to strengthen bricks and in the mortar that held bricks and stones together. 2,000 years ago, Arabians took baths in petroleum oil and water that they thought strengthened their bodies. The first oil wells were drilled in China during the 4th century. Wells dug with a bamboo pole could reach depths of 800 feet. The distilling process was discovered in the 8th century. Distilling changes a chemical substance into something else. When a liquid chemical substance is heated to the boiling point, a new kind of liquid is given off. This is called a distillate. Do you think that's a physical change or a chemical change? This is a new kind of liquid is given off, so that's a chemical change that's happening. In the 9th century, people discovered they could make kerosene out of distilled petroleum. Kerosene was a very useful distillate. People lit lamps with it and burned it in the stoves to keep warm, but they still didn't use much petroleum. Everything changed when the automobile was invented. In the late 19th century, it's the late 1800s, then petroleum became very useful. It could be distilled into gasoline, which made cars go far and fast. It worked better in car engines than kerosene did. Gasoline was cheap, and there seemed to be plenty of the crude oil needed to make it if people dug deep enough in the right places. People began digging and digging deeper and deeper to find deposits of petroleum. They learned how to put floating oil rigs out in the ocean to drill holes and pump it from under the sea floor. As people dug and pumped more and more crude oil, they made more and more gasoline in oil refineries. Refineries are where crude oil is distilled into gasoline. Gasoline became plentiful, making it possible for more and more people to drive their own cars, not to mention tractors, lawnmowers, motorboats, and other gas-powered vehicles to make life easier or even more fun. So the author has described the history of petroleum use. Does any of this information surprise you about how petroleum has been used? Another kind of fossil fuel is coal. Coal is not a liquid fuel like petroleum, but solid like a rock. It's not made from microscopic plants and animals. Instead, it is made from plants that once grew in huge swamps that covered the earth. We dig it out of the earth in coal mines and burn it to heat homes and make machines work. Some of these machines make the electricity we use. Some help people make things in factories. But burning coal also puts a lot of carbon dioxide and other emissions into the atmosphere. So what are some of the ways that coal is like petroleum? Can you think of that? Pause and think for a minute. How is it different? There is a bad thing about this. Fossil fuels such as gasoline and coal emit more carbon dioxide than any other kind of fuel. They make so much carbon dioxide because they are made of carbon. Carbon is part of everything, every living thing. We are made of carbon. The stove is hot. Carbon and me too. Lots of carbon here. So are the plants that grow in our yards and the birds and insects that live in them. When you burn carbon, it burns long and hot. But because it's made from living things or organic matter, not all of it burns. Partially burned carbon pollutes the air we breathe. It makes it dirty. And every year, the people of the world burn more fossil fuel. Captain, that glacier is much smaller this year. More and more carbon dioxide traps more and more heat above the Earth's atmosphere. Scientists who study the Earth and the environment now think the warmer air makes glaciers and polar ice caps melt. Sea levels rise, shorelines and islands shrink. Many plants and animal species cannot live in the places they always have. The world is changing, and the changes aren't good. Wow, that house is falling into the ocean. Danger, keep out. Many animals are endangered by climate change. One day, there won't be any more petroleum. It will all be used up. When it's gone, we won't be able to make any more because it was made by nature billions of years ago. It took a long time for the prehistoric plants and animals that died to turn into coal and petroleum. If people keep using these fuels, a lot more damage will be done to all living things on Earth. For nothing does more damage to the atmosphere than burning fossil fuels. We need to find other ways to get the fuel we need. We have to find ways to use less, too. And we need to find these things soon. Fortunately, there are other ways if we're smart enough to think of them and willing to change our habits. So think back on what we've read. The author describes a problem and suggests some possible solutions. What is the problem that the author describes? And what solutions does she suggest? What can you see here on this page? Which solution do you think makes the most sense? And why do you think that? We can harness and store power from the sun to make machines go. We can use windmills to harness and store power from wind. We can use nuclear energy. We can capture and store energy from waves and tides in the ocean. We can even capture emissions from factory chimneys and recycle them. That way, they don't go up into the atmosphere. We can make other kinds of automobile fuel from corn, wheat, soybeans, or sugarcane, or even water. These fuels do not put as much carbon dioxide into the atmosphere as gasoline does. It's important that we all figure out ways not to depend on fossil fuels, because this planet belongs to all of us. All of us need to take care of it. What ways can you think to help? This final page is some facts. Facts about gasoline. Find out more about gasoline, it says. Across the earth, about 83 million barrels of crude oil are produced a day, and about 83 million barrels of oil are consumed a day. There are 42 gallons of crude oil in a barrel. 1 barrel of oil can produce 19.6 gallons of gasoline. The United States consumes about 400 million gallons of gasoline a day. That equals 146 billion gallons of gasoline a year. That's more than any other country consumes. Through this incredible consumption of gasoline, the United States is releasing roughly 2 billion pounds of carbon into the atmosphere every day. Current estimates say that there are approximately 2 trillion barrels of oil left in the world. Here's some more facts. Shows what percent of these different things use the barrels of crude oil. So these are the most common uses of 1 barrel of crude oil by percentage. Percentage equals more than 100 because an approximately 5% processing gain from refining. So you have 47% of gas for cars, 23% heating oil and diesel fuel, 18% other products, 10% jet fuel, 4% propane, 3% asphalt. Here's the asphalt. And there's our end pages. All right. There's a lot to think about in that book. Why don't you head over to our discussion questions and respond with a complete sentence. I would love to hear what you have to say. See you soon.